First of all, this video is made for Codtech company. I'm thanking Codtech for giving me this opportunity. So, as I'm analyzing the dataset using Spark, so I imported the PySpark SQL and Spark session because from PySpark SQL, Spark session build the interaction between Python and JVM. So I first built that and I named it as my Spark SQL. My app name is Spark SQL. So I'm printing my Spark version, which is nothing but 3.5.3 version. And then here um, I given the format of my file. For my format of my file is CSV, and I given the header and path. My path is nothing but I have a file on my path where my Spark is in symbol. My both of my file and Spark folder is in the same directory. So the directory is nothing but local disk C, my OS. So I place my file over there, and also I have my Spark folder. This my shell, my Jupyter shell, my Spark shell on the same space, uh, on the same directory. So here I have done the two type of implementation of Spark SQL. So as a Spark SQL is needed, but I have done it in data frame. So I saved my file as a data frame by using the filter command. I just sorted over there. Here you can see this. I have readed the Spark shell. I have readed my iris.csv and store in data. And after I will just print the print schema. Just print my from root directory, spell length, spell width, petal width, finally species. So here we can clearly see that. And then in data underscore two dot print schema, we can clearly see the spell underscore length and then species because I just filtered that. My data is nothing but this is my data frame. So this is my data frame. From data frame, I just filter that using this is nothing but using my data frame API. Again, you can clearly see here. I selected these two rows and then I done that. Similarly, this can done in Spark SQL. First of all, I show the result of this because data underscore two dot show of when I give this, I can clearly see clearly see my result, my spell length and spaces, which are all above say 5.0, yeah, which are all above 5. So maximum, I think, Virginica has a maximum spell length. And then here we can clearly see that using Spark SQL I have done that. I use a command create or replace temp view. So this is used to done in Spark SQL. So I just stored it as data underscore 2. From data underscore 2, I just save this as my data, and then here I give the same command select spell length, comma spaces from data where spell length is greater than 5.0. So this show that same result. So we can clearly see here both shows the same result. And then I analyzed different analysis using ML features and then correlations. So I done my correlation matrix as well as I show here aggression, which is nothing but average of petal length, sepal length with respect to the species. We can clearly see that which has a maximum average of sepal length and petal length, and actually petal and also petal width and petal length. And I have done the data dot filter. Actually, we have seen this in previous command. Yeah, sorry, my previous code. Same as I said, it's the same code which clearly show you that sepal length and petal width. This command separates the petal sepal length which is greater than 6, and then also a petal width which is greater than 1.5. It filters all species petal width, petal length, petal width, sepal length, and shows the result in a tabular form because it's a data frame. And then I have done the command group by, so which groups are together. Here nothing but std.dv is nothing but I have done the standard deviation of it. So pyspark SQL dot functions import a exp or then if I print the data, it is nothing but it's print my column name, water roll column, and its type, species type, string, petal length, petal width, strand ratio. It's nothing but in double. Also, I clustered my model, ML model, using k-means. I think you may know about the k-means. It filters the data. Here, so you can see my model transformed and the species and prediction. I think Setosa has prediction one, and it displays that it's just a cluster making using of PySpark ML feature. So I have done another analysis, same PySpark ML feature, but here I imported my PCA. So as such, when I imported my PCA, you can see the result that PCA features, and then its set of values and with its set of values. So it's all in negative. Here you can see the accuracy of my model using logistic regression and multi-classification evaluator. So I have done two classifications and then evaluations. Also, I have show my ML features in this Spark session, and then this is nothing but my accuracy. My accuracy is nothing but 1.0, which is well and good. The Spark model is working well. Spark is working well. I can also show you the Spark. Where is my Spark is location? My Spark location. Wait a minute. So this is my command prompt. In my command prompt, so this is my command prompt. In my command prompt, I'm going to run now Spark hyphen shell. It takes some time. If you're running for first time, it take somewhat, and because when it is running first time, Spark application need to be connected and it gets scale and scalar should be shown to your Spark code. It's taking time to connect to.